Hello everyone, my name is Tam Tran. I'm in class ELET 4319, Electrical Power and Industrial Practice. Our professor is Dr. Pham, and today I will talk to you guys about Hyperloop. Now, some of you guys might already know a little or more about Hyperloop, and that's is okay because today I will get more into details about Hyperloop. And the reason I pick Hyperloop as my topic because I enjoy discussing new ideas. I enjoy telling people new technologies and etc. It excites me. It's like when you got your new iPhone or a new Samsung Galaxy phone and you be showing off to your friends the new upgrade and such that they have to offer. So that's what I want to do today is to give you guys the same excitement that I felt when I heard about Hyperloop and hope you guys can learn something from my presentation. All right, now let's get into it. So what is Hyperloop? Hyperloop is a conceptual high-speed transportation system that brought it out by Elon Musk and his team from SpaceX and Tesla. It started out ever since August 2013 when him and his team published a research paper called Hyperloop Alpha paper. And within that paper, they discuss and explain in detail how they plan to make Hyperloop into a reality, as in how it's gonna be safe, how fast it's going, how cheap it will be, the tube and capsule durability, its function, and their safety procedure. Now, their transportation will require the method will require to be using reduced pressure tube, pressurized capsules, linear induction motors, and air compressor. There'll be plenty more component inside the capsule, and I'll explain later on throughout my presentation. Now, this plan that Elon Musk brought out was only calculated from the distance from LA, California to San Francisco, California, and the distance between the two is 381.9 miles. And their plans to travel from point A to point B within 35 minutes. That's crazy, correct, right? Now you would think it's a crazy idea, but that's because you don't know who is Elon Musk. Elon Musk, he is a entrepreneur, he is an engineer, an inventor, and an investor. He is the CEO and CTO of SpaceX, CEO and product architect of Tesla Motor, chairman of SolarCity, and co-chairman of OpenAI research company. And most of us don't know this, but three of his companies survived the Great Recession of 2008, and which are SolarCity, Tesla, and SpaceX. That's mean you kind of understand that he actually went through a tough time in his life. He take care of his companies and ideas like his own children. He makes sure that they did not went bankrupt. And because of all of this reason and backgrounds of his life, I believe that Hyperloop will one day become a reality. Now, the Hyperloop idea was not a brand new idea that Elon Musk introduced. This idea was way back in the years the 1900s. In the New York City, there was a subway transportation tunnel called the Interborough Rapid Transit Subway, which kind of successful until 3 years later the idea was abandoned due to the lack of safety precautions and not a reliable braking system that they have. Now, as of right now in the modern day, I believe that we have the right technology and the right mind to make this idea come to reality. So, how does Hyperloop travel? Well, Hyperloop it travel through a cushion of air. They use a method or theory called aerodynamic lift, and they would also require components called an external electric motor, aka round induction motor, to accelerate. Now, the definition of aerodynamic force is acting on an airfoil that opposes gravity. Basically, by traveling in extreme speed, we can speed through the tunnel while on a cushion of air. So first off, what happened is the electric motor accelerate and push the capsule forward. Then the vacuum will pick up the wind, and as the air passes through the vacuum, the air will divide it onto the top, bottom, and the side of the capsule to keep it in place while traveling through the tunnel. And at every 70 miles, the electric motor will kick in to give it another boost to keep it at the desired speed of the capsule. And the speed that they are looking for is Mach 101, which very low friction that they can travel on the surface of air. So, like any other mass transportation system, they always want to create a way to appealing to the consumer. Therefore, in Hyperloop, Elon Musk want his to be safe, fast, low cost to travel, immune to the weather, and sustainably self-powering. Now, this plan is from Los Angeles to San Francisco and vice versa. It's a two-way system. So how can this be safer for passenger who travel very high speed from point A to point B without feeling nausea, sickness, and other kind of issue that involve in high speed transportation? Well, a student from one of the competition that Elon Musk started, they have a architect design where they could make the seat in the capsule more comfortable to the passenger, allowing them to sit down in position where they can relax and rest. Second, they're gonna have a digital landscape displays around the cabinet, allowing them to have a visual view of relaxation. Third, they're gonna have a AR window for each passenger, allowing them to have a personal entertainment. And most importantly, Hyperloop system are expected to have a service life to be 100 years, according to Elon Musk. Now, how can it be faster? So, in the Hyperloop transportation, they have they call it propulsion system, which is have a basic requirement is first to accelerate the capsule from 0 to 300 mile per hour for relatively low speed travel in urban area. Second, to maintain the capsule at 300 mile per hour as necessary, including during ascent over the mountain surrounding Los Angeles and San Francisco. 3. To accelerate the capsule from 300 to 760 mile per hour at 1 g at the beginning of the long coasting section along the I-5 corridor. 4. To decelerate the capsule back to 300 mile per hour at the end of the I-5 corridor. So to make the system possible, we have several components in the capsule. First, you have the inlet to let the air going through the compressor fan. Then we have the air storage for case of emergency and cases for lack of air going through the bottom, top, and the side. Then we have a compressor motor. We have the firewall to block off in case of any malfunction. Then next we have the seating. And lastly, on the back, we have the battery, which is allowing the capsule to reboost itself every 70 miles. And at the bottom of the capsule, we have suspension, which where the air push out, allowing to have a cushion of air, allowing the capsule travel through the tunnel. Now let me explain more about suspension in the Hyperloop system. Elon Musk and his team wanted to use this method called air bearing, just like the hockey table that we used to play in the arcade. What air bearing does for this capsule is that it will stabilize the capsule in the tunnel and also keeping the height at a level allowing the capsule not to have a contact with the tunnel. Now, what air bearing does is also push down the air through the suspension, allowing to have an air cushion while it's traveling through the tunnel, basically like a vacuum. Now, after going through all of the components that needed for the capsule, let's talk about the cost. How much this system would need to get it out there. Now, in the Hyperloop Alpha paper that Elon Musk published, there were two versions of this capsule. One is for passenger only, and the second one is passenger with cargo. That's mean you can travel with a vehicle inside. For example, I can sit in my Toyota Corolla while traveling through the tube. Crazy. I can't believe it. Now let's first go through the passenger version cost. First we have the capsule structure and doors, interior and seat, the propulsion system, suspension and air bearing, batteries and motor and cooling, air compressor, emergency braking, general assembly, passenger and luggage. The total per capsule would cost $1,350,000. They would all weigh 15,000 kilograms. And the total cost for the entire Hyperloop system would be $54 million. Now the difference between the cargo and the passenger version is that they will have to account in the car and the cargo, which will have an increase of 175,000, and that will make the total for the Hyperloop system to be $61 million, and the weight will be increased to 26,000 kilograms. Now for this section, I'm going to go through the passenger and the cargo with passenger version, including the cost of the tube. So with the tube construction, the pylon construction, tunnel construction, solar panel and battery, station and vacuum pump, and permit and land, the cost margin will be another $6,000 million in the US. Now with the cargo, you will have a separate capsule for the cargo, and that total would cost to $30.5 million in the US. That will cost, including the tube, will raise up to 7,500 million in US dollar. For the passenger only capsule, it can carry 28 passengers each that travel along the interior of the tube, depart on average of every 2 minutes from Los Angeles to San Francisco. Now for the cargo with the passenger version, it has been sized that allows to travel of 3 full-size automobile with passenger to travel in the capsule. The capsule are separated within the tube by approximately 23 miles on average during operation. And of course, the capsule are supported via air bearing that operate using a compressed air reserve and aerodynamic lift. Now for the tube construction, the tube will be made of steel. 2 tubes will be welded together in a side-by-side configuration to allow the capsule to travel both directions. The pylons are placed every 100 feet to support the tube, and there will be solar array covers the top of the tube in order to provide power to the system. Now for the propulsion, the linear accelerator are constructed allowing the length of the tube at various locations to accelerate the capsule. The rotor are located on the capsule to transfer momentum to the capsule via to the linear accelerator. Now for the route, there will be a station at Los Angeles and San Francisco, and there will be several other stations along the way that will be possible with split in the tubes, allowing passenger to get off at specific station instead of going straight through to San Francisco or straight to Los Angeles. And the majority of the route will follow I-5 and the tube will be constructed in the median. So how does the Hyperloop system immune to weather? Well, in the paper it didn't specifically tell you the exactly how they immune to weather, but they basically say they are carefully control and maintain the tube environment while you're traveling through the tunnel. And according to the paper, it says it's safer than airplane, train, or automobile. Now, this is just a concept theory. It haven't been yet constructed or tested yet, so that is still a maybe. But one of the thing I'm certain is that it withstand rain, heat, snow, since it's traveled with inside a tube, it preventing the environment around it to affect the capsule itself. Now, for earthquake, it will be a different scenario because in California, now for Hyperloop to have a sustainably self-powering system, Elon Musk and his team decide to use solar panel array that run 24/7 that place on top of the tube, allowing it to collect energy from the heat from the sun to convert to energy and store it inside the battery within the capsule. Then they will have also have an electric fan that can be in reverse to generate energy like a light cell. So back to the solar panel array, the Hyperloop can generate far in excess of the energy needed to operate. This takes into account of storing enough energy in battery pack to operate at night and for period of extended cloudy weather. The energy could also be stored in form of compressed air that then run an electric fan. And that's what I'm talking about when it's trying to generate energy, same as the light cell. From the look of this one line diagram of the solar panel array system, they will be having varieties of solar panel array throughout on top of the tube, which give them the peak power of 285 megawatts total, going in through 6 megawatt grid connection and grid ties inverter. They will have then it's going through the HVDC bus and dispersed through the energy storage and also to the traction inverter, dispersing out 70 megavarts each. And the energy storage can store up 38 megawatts per hour. The peak power will be 56 megawatts. After going through the traction inverter, it will go through two lines that will go through four motors, top and bottom, and each motor they will have a solid state switch in case of malfunction. And depending on the speed, the traction will need either 20 megawatts or in high speed will need 50 megawatts. According to this chart published by Silbra Studio, a studio at UCLA in architecture school, show just how the Hyperloop stack up to its competition, and the results are impressive. And the result are very impressive. Just look by the speed comparison. It says according to here, Hyperloop can travel from 500 to 550 miles per hour. Now from the paper that I've been reading on, researching on, it say it can reach up to 760 miles per hour, but we can never sure. but the speed compared to Hyperloop speed to the highest speed to the traditional transportation, which is the airplane transportation, is only lower by 50 mile per hour. But from the look at the frequency category, airplane travel in the air approximately 50 airplane per day. Now for Hyperloop, the frequency can travel is every 30 seconds to 20 minutes per trip. Now we see that the Hyperloop system can offer faster speed, it can be very cheap, and it's safe for the environment. Now we have to see if it's safe for us to travel through its system. Well, according to Elon Musk, if there ever an emergency on board, they will have a radio that can direct contact with the station operator, and they also have the first aid equipment. So now they have to consider into power outage. Well, they wouldn't be worried about that because they will have an external battery lithium ion battery pack, just like in the Tesla Model S, that can power the capsule through its trips. And of course, they will have a mechanical brake system in case of the tube damage and blocking their way, allowing to stop while traveling. And they will also have a pressure sensors as well as sensor on each capsule, allowing the capsule before the previous one to detect what happened in front of them so they can stop prior to before heading to a collision. Now, in case of a capsule stranded in the tube, there will be a power deploy wheel that will take them to their destination, and also there will be a reserve air supplies for passengers while it's taking them to their destination. And of course, they will have a standard maintenance check from time to time, as well a pressure sensor. As of right now, there is two current competition out there. One is Hyperloop technology, and another one is Hyperloop transportation technology. Hyperloop technology, they are planning on building one in the United Kingdom, and the Hyperloop transportation technology, they will build theirs at Las Vegas, Nevada, to test out their Hyperloop within 2 years from now or so. There is a third competition, but I didn't actually find enough information that could provide onto my PowerPoint. So as a conclusion, in Elon Musk's paper, there's two versions of his plan. One is for passenger only, and one's for passenger including vehicle version. And the trip from point A to point B, Los Angeles to San Francisco, will be only 35 minutes. It will take around $6 billion to build and can be paid back within 20 years, giving it's only $20 per person one-way trip. And this is all of my reference. Firstly, most of the information I have gathered is through Hyperloop Alpha paper. I gather one data from Fast Company News, some of the pictures I collect from theirs. Next is the Hyperloop technology. I collect some pictures and information for my current competition slide. Then one from Tech Insider, where I collect one of their pictures for my slide, as well as Daily
mail and see what was the third competitor out there, which is, I believe, is Arcom. And I give my thanks to my professor, Dr. Pham, for giving me the opportunities to discuss about these topics, which I really look up for and hopefully will come into near soon future. Thank you and have a lovely night.